Hi, my name is Braden Barbary, and this is my Physics 2212, Lab 3 on circuits. So for an introduction, the point of this lab was to test concepts that have been learned in class with a real-life circuit. The circuit was tested using resistors, capacitors, and multimeters, and in the end the predicted readings on the multimeter were only able to match up for some of the tests. And in the lab, the circuit was the system, and everything else was the surroundings. The physics principles used in this lab were the node rule, which shows that the current flowing into a node must equal the current leaving the node. This law shows the conservation of charge. The loop rule, which shows that the potential difference around an entire circuit is zero, and Ohm's law, which shows that the voltage equals the current times the resistance. With testing Ohm's law, the formula that I just showed was used. To find the current in the circuit, you solve for I. The voltage is 3 volts due to there being two 1.5 volt batteries. The resistance is 147 ohms because you add the resistance of the two resistors together, and that formula ends up being I, which is the current, equals 3, the voltage, over 147, which is the resistance, and that is 0.02 amps. And this is the model of the circuit with the two batteries each totaling to be 3 volts, an ammeter, the 47 ohm resistor, another 100 ohm resistor that you add together, and then back to the batteries. For testing Ohm's law, again, the expected voltage was unable to be found due to only having access to a multimeter, but theoretically, if one of the connections of an ammeter were reversed, the current would become. What would happen if an ammeter was replaced with a voltmeter? The remaining ammeter would read 0 amps because the voltmeter takes up all of the charge due to a high resistance. The voltmeter would read -3 volts because there has been no drop in voltage before the voltmeter. Testing the loop rule. The loop rule is used to create an equation for the voltage drop throughout the circuit. And this is V equals IR to find the voltage from the two resistors, the 0.202 amps of circuit times the 147 ohms of resistance, and you get a 2.94 voltage drop between the resistors. So if you take the voltage of the batteries and subtract the voltage from the resistors, and then subtract the rest of the voltage difference, that will equal 0. And the rest of this voltage difference comes from the wires and the ammeters taking slight bits of voltage. And this shows loop rule because if you start at a point, say here, and you go through the two batteries to get +3, as you go through the rest of the circuit, it will slowly lose voltage until it gets to 0, back at where it started. And this graph shows what I just said, which it goes through the batteries to get to 3 volts, and then drops from the first resistor and then drops from the second resistor. And this graph does not show loss of voltage throughout the wires or ammeters because it cannot be predicted where this loss is actually coming from. RC circuits. Using a 9-volt battery, a 200 millifarad capacitor, and a 30 ohm light, the RC of the circuit can be found. And that RC equals the 30 ohms times the 0.2 farads to equal 6 seconds as a predicted RC. Now the experimental RC is found by taking 1 over the absolute value of the slope, and that's 6.8823 seconds. And this slope comes from observed data in the lab of the natural log versus time graph. And this 0.8 seconds difference is from the added resistance throughout the circuit that is not from the light. What if a capacitor were charged with no resistor in the circuit? Theoretically, the capacitor would charge and discharge instantly. The RC would equal 0 seconds because RC equals 0 times capacitance will always equal 0. In practice, this can never be found because there will always be some resistance. Assumptions and possible errors. Assumptions were that the batteries were assumed to be fully charged even though there had been previous use, and the loss of charge throughout the wires and ammeters were assumed to be minimal. Possible error was using the multimeter and ammeter and them being improperly calibrated. In conclusion, the physics principles worked with what was found relatively closely. However, the principles did not account for the loss of voltage throughout the wires and ammeters, and this difference makes the experimental cases slightly off from what would be predicted.